let's take a look here at problem number 2. Excuse me, we want to evaluate this integral here by changing the order integration. So first off, note that as given, as stated here, we have to integrate with respect to y first. Coming up with an antiderivative of this with respect to y would be a very difficult process. I sure don't know what an antiderivative of e to the y fourth, that x is a constant with respect to y. I don't know how to come up with an antiderivative of this. So what we want to do, we want to write this as an integral of the same function, x e to the y to the fourth, but now have the x integration come first and then the y integration. So in order to do this, this is going to require changing the bounds, which is not simply just writing the bounds in the opposite order, because we'd have non-constant bounds on the outside, and that's bad. We need to draw a picture here. Okay, so let's figure out what is going on here for the bounds here. So x can be anything from 0 to 1. The upper y bound is 1. And the lower y bound is, this is y is equal to x to the 2/3 power. And so x to the 2/3 power will look something like this. And so as x runs from 0 to 1, the allowable y values run from y is equal to x to the 2/3 to y is equal to 1. So it's this region right here, the top left region. A very common mistake would be to identify it with the wrong region, the bottom right region, so don't do that. Realize here for fixed value of x, y runs from x to the 2/3 up to 1. So now what we're going to do, this region here is both vertically simple and horizontally simple, so we're going to slice it this way instead to be able to write this out in the dx dy order. So we can see, slicing it this way instead, y runs from 0 to 1, x runs from 0 to this curve right here. Y in terms of x is y is equal to x to the 2/3. We want to write this x in terms of y. So this is x is equal to y to the 3/2 power. And that gives us an upper bound here. So y runs from 0 to 1, x runs from 0 to y to the 3/2, x e to the y to the 4th, dx dy. This is the integral that we want to evaluate here. Okay, so integrating this with respect to x here, integrating this with respect to x gives us x squared, but e to the y to the 4th is a constant with respect to x squared over 2. Plug in x from 0 to y to the 3/2. And let's see here, x equals 0 will just give us 0. Y to the 3/2 squared will give us y cubed, e to the y to the 4th dy. And so take a look, what did changing the order integration accomplish for us? It allowed us to now have this factor of y cubed appear here. And so now, this is a relatively easy integral to evaluate by substitution. U is equal to y to the 4th. Du is equal to 4y cubed dy. We see that y cubed dy here. So rearranging du over 4 is equal to y cubed dy. There is our y cubed dy. So let's see, what do we have here? We have a 1/2 and a 1/4 out in front. When y is 0, u is 0. When y is 1, u is 1. Bounds are still 0 to 1, but now it is du. And e to the u right there. So our answer here is 1/8. Antiderivative of e to the u is, of course, just e to the u. Plug in from 0 to 1. It's 1/8 times e minus 1.